Okay, so you know how much we love to just dive deep into the really weird stuff in physics, right?
Oh, yeah. The deeper, the better, I always say.
Well, this is a doozy.
All right, let's hear it. Lay it on me.
You sent us a note about something called Majorana 1.
Right.
And honestly, I got to say, that's not really ringing any bells for me, or as far as we can tell, anywhere in the scientific community.
Uh-huh.
But that word Majorana, now that's a whole different story.
Yeah, there's some serious physics juice in that name.
Oh yeah, we're talking about Majorana fermions.
Buckle up.
These things are particles that are so bizarre, they're their own antiparticles. It's like, what?
Yeah, it's one of those concepts that just like warps your brain a little bit when you first encounter it.
It really does.
Because, we learn in physics that every particle has an antiparticle, right?
Yeah, it's like the evil twin.
Yeah, exactly.
Yeah.
It's the evil twin with the opposite charge. And when a particle and its antiparticle meet, they annihilate each other. Poof,
Bing.
gone.
Right, pure energy.
Yeah, exactly. But then you have these Majorana fermions, and they're like, nope, I'm good on my own antiparticle.
So they're like matter and antimatter all in one? How does that even work?
Yeah, it's mind-bending, isn't it? To understand it, you kind of have to dig a little deeper into properties like charge and spin. So you know how, imagine a particle spinning one way, its antiparticle would be spinning the opposite way.
Right, okay.
But with a Majorana fermion, theoretically, their spin is, well, it's ambiguous, let's just say. It's like it can be both and neither at the same time, which allows it to be its own antiparticle.
So where do we even begin to look for something like this?
Well, there are a few really intriguing places. One of the most promising is in neutrinos.
Neutrinos, those are like what, the ghosts of the particle world?
Yeah. They're tiny, almost massless. They zip through pretty much everything. And some physicists think that neutrinos might actually be Majorana fermions.
Which would be huge, right?
Absolutely massive. I mean, one of the biggest mysteries in the universe is why there's so much more matter than antimatter. And if neutrinos are their own antiparticles, that could help to explain how the universe tipped the scales in favor of matter back during the Big Bang.
Okay, so that's the cosmic scale. But our research also turned up some interesting stuff about potential applications. Specifically, Majorana quasiparticles and quantum computing. Something about ultra-stable qubits.
Oh, yeah. This is where it starts to get really, really exciting. Because, so first you've got to understand these quasiparticles. They're not actually true particles like electrons or protons.
Right.
They're more like, collective excitations that behave like particles in certain materials under specific conditions.
Okay.
And it turns out that some of these quasiparticles, they exhibit Majorana-like behavior. And if we can figure out how to harness that, oh man, we could be talking about quantum computers that are so much more powerful than anything we've got today, like orders of magnitude more powerful and stable.
Stable quantum computers. I mean, what could we even do with something like that? What would that look like?
Well, for starters, we could simulate complex molecules like it's nothing. We could design completely new life-saving drugs. We could model climate change with incredible accuracy. Heck, we could probably crack encryption codes that would take conventional computers billions of years to even scratch the surface of.
Wow. Okay, that's a game changer for sure.
Yeah.
So where does this Majorana 1 thing fit into all this? I mean, could this be some kind of secret project, a research program that's trying to unlock these applications?
Well, it's certainly possible. Majorana 1 could be, an experiment that's trying to detect these elusive particles, maybe searching for, signatures of their unique behavior in exotic materials or, diving deeper into those neutrinos we were talking about.
Okay.
Or maybe it's some super advanced theoretical model, a simulation that's paving the way for future breakthroughs.
So it's like this tiny little breadcrumb leading us down this rabbit hole of possibilities. And they all stem from this mind-blowing concept of a particle being its own antiparticle.
It's wild, right?
It's absolutely wild. And the craziest thing is every new discovery, every experiment, it just brings us closer to really understanding the implications of Majorana fermions, which honestly, it's kind of hard to even wrap your head around,
Yeah, I remember when I first learned about this stuff, I thought it was like pure science fiction, straight out of Star Trek,
Yeah.
But the more we learn, the more we realize that, maybe these particles aren't science fiction after all. Maybe they're a lot closer than we think.
Which brings us to a question that we want to leave you with today.
Hmm.
What if we're made of particles that are their own antiparticles? What if the very building blocks of us, of everything, have this fundamental duality within them? Could Majorana 1 be the key to unlocking that secret? It's a mind-blowing thought for sure, and one that we hope you'll keep pondering as we continue to explore the mysteries of the universe together. Until next time, keep those minds curious.
And don't be afraid to get a little weird with it.
Absolutely.